negative 1. If it's at negative 1, it has a multiplicity of what? Why does it have a multiplicity of 1? It's going straight through. Even if it's kind of going straight through at a bend, it is still going straight through. Does that make sense? Okay. My next 0 is where? At 2.5. Okay, it's not perfect, it's not always even. At 2.5, what's happening? Straight through, which means has a multiplicity of 1. My last 0 is at where? At 4, and what's happening at 4? It is bouncing, so it has a multiplicity of 2. Add up your multiplicities. You get 6, correct? 2, 3, 4, 5, 6, yes? Yeah. What did I tell you your degree had to at least be? 6. This is a way to check. Is it always going to add up perfectly? No. But if you got 7 and you thought the multiplicity should be 6, you've either read your graph wrong or you don't know how to count. Okay? No, relative extremity you don't add. The degree is what you add to. All right, I need you guys to do the next 2 right now, please. Do the next 2 examples right now, please. All right, start checking it to make sure yours matches mine. So that should match up 100% with what you have. And there's your last one. Above even positive. Now, what do we think the degree should be? No. It should be 4. That's what we think, right? But my zeros tell me it's possibly what? 6. Now, why did I say possibly? Here's the deal. A bounce can be any multiplicity, any even multiplicity. So it could be really a 4. I have no idea. But a through is always going to be 1, and a curve is always going to be 3. 5 is going to be a straight through, but you're not going to have to worry about that. Okay? Does that make sense? Yeah? Okay. Now, so when we graph these are things that you're going to want to make sure you're paying attention to. Use the leading coefficient test. Find the x-intercept set. My equation equals 0. You might have to factor. It might already be factored for you. Not always done. Here's those rules. If you weren't here on Monday, there's those rules that you're going to need. I'm not going to ask you to find the y-intercept right now. Here's why. When we graph these, you're not going to have values on the x-axis. They're not going to be like 1, 2, 3, negative 1, 2, 3. So there's really no point, in my opinion, of you finding it right now. This is important, though. Make sure you are counting how many maximums and minimums you have to match your degree that you think it should have. Yes? Capiche? All right. We're going to graph 4 of them right now, and you're going to see how I want you to go step by step with it. So the first one is right here. It says leading coefficient. I want leading coefficient, I want even and odd, and I want the end behavior. First one, leading coefficient, positive or negative? Positive. Even or odd? Even. So then it is what? Up, up. Is everybody okay with those? You should hopefully remember this from last year. We did this for a long time last year. This is like almost 2 weeks ago. Okay. Now, x to the 4th minus 29x squared plus 100. You have to set that equal to 0. So if I set this equal to 0, how am I going to find my actual 0? You have to factor. You have to factor. Well, what multiplies to 100 that adds to negative 29? Negative 25 and negative 4, though, right? Yes? But how do I factor it? I know it's negative 25, and then I know it's negative 4. X squared. Your middle term tells you the variable and power for which you should put in that first little section. Do you remember from Monday what I told you? Is this 100% factored?
No.
Now, in previous math classes, was this 100% factored?
Yeah.
Yes. In my class, it's not, because you got to actually find those zeros. How do I factor x squared minus 25? So that's x minus 5x plus 5, right? Difference of 2 squares. Yes? What if it's not a perfect square? Can we still do it?
Yes.
Remember we did that on Monday. X squared minus 4, x minus 2x plus 2, yes? So equals 0. Yeah? Okay, I need to find my x-intercepts and their multiplicities. We're not going to find the y-intercept, so I'm just going to kind of keep using space. How do I find my zeros in factored form? Set them equal to 0 and go, right? So my first factor gives me a 0 of what? 5. How do I know what the multiplicity is? Exponent attached to what? Exponent attached to the factor. Exponent attached to a factor. Because these should always be to the first power, yes?
Yeah.
You can't leave it if it's not to the first power, not factor. So this has a multiplicity of 1. My next factor, my 0 is negative 5, yes? Has a multiplicity of 1. My next factor, set equal to 0 and solve it, will give me a 0 of 2 with a multiplicity of 1. The last one is negative 2 with a multiplicity of 1. Yes?
Yeah.
Now, here's what I do when I go to graph this. I always sketch my x-intercepts out first. So I have one at negative 5, negative 2, 2, and 5. Yes? Now, I also kind of want to recognize that my end behavior is important. What's my end behavior for this example? It's up and up. Now, you're going to see me put it above my last 0, or my first 0, and the last everyone thinks about. Why am I putting it above those? Because that's where it's going, right? You're not going to come back down anywhere else from there. So, now what I do from here, don't just draw it. I would suggest you use what it means as a multiplicity of 1. Because when it gets to be a multiplicity of 3, if you draw it the wrong way and you don't have an idea of where it's coming from, your whole graph's wrong. Okay? What's happening at negative 5? What's my multiplicity? It's 1, so it does what? Straight through. What about at negative 2? What about at 2? And what about at 5? I would suggest you not try to cut corners and make a mistake that could easily make your graph all wrong. Now, I would just connect them as best as possible, like so. Okay? Next example. Positive or negative? Even or odd? So that is up, down. If you don't have those memories, I would have to memorize tomorrow. The more you have memorized for tomorrow, the less you have to flip back through your notes. If you have to flip back through your notes, there's a good chance you might not be able to finish. All right, is that factored? No, so I have to factor it out. What am I going to do first if I tell you to factor it out? I'm going to GCF it. And what is my GCF? Negative x cubed. Why do we want the negative? You want the leading coefficient to be positive when you factor it. So I have negative x cubed. So then I have 2x squared plus 5x minus 3 equals equals 0, yes? Okay. How do I factor it? That's AC method. Now, remember the beginning of the year. I told you, I'm going to spend 2 days factoring. Anytime I factor from those 2 days, I'm expecting you to just go. This is a clear example, is if you're not awesome at factoring, it's time to start practicing on your own. The negative x clear to the third cannot go away. You got to keep it there. It's part of your factor. First term down, last term down. You still have to have an equals to 0. You want to see a picky greater when it comes to certain things. If you're finding your zeros and you don't have it set equal to 0, I will take a half point off. Because just factoring and finding zeros are two completely different things. How do I find my middle terms? What multiplies to 2, or what multiplies negative 2 and 2 and negative 3 is negative 6. What multiplies to negative 6 that adds to 5. 6 and a negative 1. So I'm going to have a plus 6x, and I'm going to have a minus x. Yes? 4 terms. How do I factor 4 terms? Group it, right? So I have negative x cubed. What's my GCF? GCF of my first group. 2x. I'm left with x plus 3. My GCF of my second group. Negative 1. I'm left with x plus 3. Still equals 0, yeah?
Yeah.
Last thing. Negative x cubed times 2x minus 1 times x plus 3. This still equals 0, yeah?
Yeah.
Am I completely factored now?
Yeah.
Yeah, because technically this isn't an x linear. Remember I said that on Monday? They all gotta be like x, blah, blah, blah. If it's a GCF, and it's by itself, GCF is probably gonna be it by itself, right? Either x or x squared or x cubed. You can't factor. I mean, could you write negative x times x times x? Yeah, but is that stupid? Yeah. Okay. So is that factored? Yes. Now I find my zeros. How do I find my zeros? Set all my factors equal to 0. What's my first factor?
0.
Negative x cubed is my first factor, right? So that means it's a 0 at 0. And what is my multiplicity?
3.
It's 3. Remember, it's the exponent attached to the factor. Because technically that x could be in a parenthesis. My next 0 comes from here. How do I set that? I set that equal to 0, yes?
Yeah.
I do what first? Add in. So it is 1/2, which has a multiplicity of 1. My last one. Set equal to 0, I would subtract 3 has a multiplicity of 1. Yeah?
Yeah.
Okay. Now, graph your zeros. Negative 3, 0, and 1/2. What's my indicator? Up, down. Okay, now, when it's different direction, guys, listen to me, this is important. When it's a different direction, I would suggest you go from the left to the right. Especially if something bounces or it curves. Because if it curves the wrong direction, your graph's wrong. Alright, so what's happening at negative 3? Straight through. What's happening at 0? It bends, right? So, do you see how if you don't do it in the right direction, is this going to bend up or bend down? I'm coming this direction. It's going to bend up. Do you see what I mean by sketching these out makes it easier? Does that make sense? So it's going to bend up, so it's going to look something like that. And then what happens at 1/2? It comes back down. So then you can connect it like so. As long as I can see the bend, it doesn't matter. I have to be able to see, guys, this is important. I have to be able to see that it goes straight through. I have to be able to see that it balances. I have to be able to, if this bend looks like a straight line, I'm not going to count it. What were you going to ask me? No, what were you going to ask me? Sure?
Yeah.
Okay.
So if the end of our, if the arrow we put If we put it directly above the x-intercept,
And it curves a little bit, it's fine.
I mean, if it's a straight line, is that,
These are expected, and I'm assuming you guys want to know this to be a function, so I'm not looking. Okay, now, if we look at examples 1 and 2, and then we look at examples 3 and 4, what have I changed? It's already factored. Let me be really honest with you. You want them already factored every single time. You know why? You don't have to factor. Some of you, factoring is not your strongest suit. So you want me to put all kinds of these on there because they're a little bit easier. But there is one thing that will trip you up, and I promise it will happen right about now. All right. Leading coefficient, positive or negative? Positive, even or odd?
Even. Odd. Even, you have to distribute the x.
Or even get one.
No, there's a three.
it's already done.
There's a three.
It's already, yes, it's three
Oh,
or
it's a one. No,
It's a three
it's a
or
one.
one.
Neither, neither, neither.
That was-
It's odd, but not because it's 3.
Yeah, no.
Why did we got that?
It's not 3.
One.
No, it's not 1. It is odd because you have to add your exponents. It's not odd. It's even.
You just said it was odd.
You're multiplying them. How-
You just said it was odd. Said it was odd.
It's even. It's 6. 3 plus 2 plus 1 is 6. This is even. If it's already factored, do you see why I told you there's a piece that's going to cause an issue? Did we just find that piece?
Yeah.
If it's already factored, you must remember you have to add your exponents. You have a 1, you have a 3, and you have a 2, so it's 6, yes?
Yes.
Then, leading coefficient test, up, or down, down? Up. Now, when it's already factored, and technically we probably shouldn't have done it with these. My degree is 4 for this, yes?
Yeah.
How many maximums and minimums do I have?
3.
Does that make sense?
Yeah.
Okay? Especially when it comes to these, this is how you're going to be able to tell if you have counted your degree right. All right? Intercepts and multiplicities. My first factor is just x, correct? So that means I have a 0 at 0, and my multiplicity is 1. My next 0 is where? Negative 3 has a multiplicity of 3, and then 2 has a multiplicity of 2. Okay? So when I go to graph it, I have negative 3, I have 0, and I have 2, correct?
Yeah.
All right. Now, at negative 3, what happens? It bends. Does it bend down or up? Why is it down? It's going up, right? So it's got to bend down. Okay. At 0, what happens? Straight through. And at 2, what happens? It bounces. So it's going to come back, and it's going to bounce, and it's going to go back up. Now, how many maximums or minimums do I have? 3. So what do I think my degree could possibly be? 4. But what do I know it is? So is my graph correct? Yes, because it has, we know it's at least 4, and 6 is an even multiple. Does that make sense?
Yeah.
Okay, I would like you guys to try the last one, please.
Jake opens the door and goes, 7 goes.